Welcome back to tutorial series. We discussed that there are two ways to solve linear differential equations. The first one is matrix method and the other one is diagonalization method. In the previous videos we learned matrix method and now we'll be learning diagonalization method. So here the format is as usual. There is a system of linear equations which you'll be putting in the form of matrices. So here you have d by dx of x1, x2, x3 and you have the corresponding coefficients x1, x2, x3 and you have the functions. If these are 0, it is homogeneous, and if these are not 0, it is non-homogeneous. So this is of the form x dash is equal to ax plus f. Let's assume that x is equal to py. Let's assume that, and where your p is going to be x1, x2, x3. So what will be x dash? X dash is equal to p into y dash. Now you know that x dash is equal to ax plus f, which you obtained from here. So when you compare these two equations, py dash is equal to apy plus f, because you're trying to substitute py in the place of x. So this is your final format. Now trying to apply P inverse, you get y dash is equal to P inverse APY plus P inverse F. You might find that the method looks similar. Yes, it is the same method which we followed in matrices lesson to find your diagonal matrix. So we follow the same format here. Here you have y dash is equal to dy plus P inverse F. So where D is your diagonal matrix, P inverse AP. I think you can recall it now. This is the reason why we are taking x is equal to py. We are considering it so that you can come to this relation and your solution process is easy. Now since it's y dash, you can, since you have x dash, you mention it as x1, x2 and x3. Here you have y dash, you can mention it as y1 dash, y2 dash and y3 dash is equal to d into y1, y2, y3 plus those functions f1, f2 and f3. Now you have, you obtain y1, y2 and y3 from this. To be honest, you obtain y1 dash, y2 dash and y3 dash from here. On integrating, you obtain y1, y2 and y3. So you already know that x is equal to py. From this we can directly obtain x1, x2 and x3. This is the general format of how you will follow this method to obtain your solution. Here it's P inverse F, that is you're following the same format and substituting the corresponding values of the matrices. Here's your first example. Let's consider that the equations are in the form of x dash is equal to ax plus f, where this is a, you have x dash x and this is f. So a minus lambda I is equal to 0. You apply this to find eigenvalues. From that you obtain the eigenvectors. Now you have two eigenvectors, two different eigenvectors. So you follow the general format. Now you are trying to find p, which is of the form x1, x2. So putting your eigenvectors here, you obtain this, and you know that your D is given by P inverse AP, and you also know that the shortcut form to verify if your diagonal which you are obtaining by multiplying P inverse with A and P is that your diagonal matrix will have the eigenvalues as the elements in the diagonal, right? So when you try to multiply P inverse with A and P, you obtain D as 0, 0, 0, 5. Now you try to substitute all the matrices you have into the equation. Y dash is equal to dy plus P inverse of f. You have D, you have y plus P inverse. You have P. So P inverse is this. When you find the inverse of the matrix, you obtain this, and then you have the function. On trying to solve these, on trying to multiply these two, and on trying to multiply these two, you obtain these. So here two equations are y1 dash is equal to 1 by 5 e to the power of t, and y2 dash is equal to 5y2 plus 7 by 5 et. Now, when you try integrating these, you'll be able to obtain your y1 and y2. How do we integrate these? You can either follow the format you followed in the third module to obtain y, that is to find the solution of differential equations, or you can solve these using the method you learned in the fourth module, that is using Laplace transformation. So any method would work. So you will be able to find y1 and y2 from y1 dash and y2 dash using any of those methods. Now you know that x is equal to py. Substituting p and y in their corresponding places and solving them, multiplying these two matrices, you obtain this. So x1 is equal to this equation and x2 is equal to this equation. These are your solutions. Here's a remark for you. Matrix method fails if the function is of this format, that is a1 e to the power of at plus a2 e to the power of bt, where a and b are both are eigenvalues of matrix A. So if A or B or both are eigenvalues of the given matrix A, or eigenvalues you obtain from the given matrix A, then the matrix method would fail. In that case, please be cautious to apply diagonalization method. Here are a few practice problems. To practice them, so follow the same format as we followed above to find the solutions.